Hi everyone, and you are welcome to this lecture, Math Module. In this lecture, I'm going to define what a module is because this is the first time I mentioned this word module in this course. After that, I'm going to explain what math module is, and we will see some available functions in this module. So we will see some general functions, rounding functions, trigonometric functions, mathematical constants, and I will end up this lecture by a quick summary. So let's get started. So, what's a module? Simply, module is a Python file with .py extension. It's exactly like the file that you already created and you write your code in right now. In Python, we have a lot of available built-in modules or third-party modules. And in this case, we called module a library because it has some ready code for you to be used directly. And this code has been written before by somebody and make it available for you. You have to keep in mind that whenever you want to use codes from a module or a library, you must import that module to your workspace. In Python, we have the keyword import to import module into our workspace. And we use it in this way. We say import and then we put the module name. Now let's talk about math module. Math module is a built-in module. In other words, it comes with the original Python package and you don't have to install if you want to use. This module is full of mathematical functions that you will use a lot in your programs. For example, we have power function, square root function, absolute value function, and so on in math module. Now let's move to PyCharm IDE to see some of available functions inside math module. First of all, to use math module, you have to import first. And as I mentioned before, I have to use the keyword import. And the module name is math, then run. As you see, there is no error, and now math is ready to be used in our workspace. I will define a variable x, its value 4. And then I will use this variable inside the available functions in math module. For each one of these available functions, I have added a description in this code file. So the first function I want to introduce is exponential function. And you will note that for each function, I will write the name, then the parameters that this function takes, and what is the type of that parameter. For example, in this case, exponentiation function take x, and this x should be integer or float. And this function will return a number, which is going to be a float number. What this function does, it returns the value of ex, where e is known as the Euler number. And this number is very common in mathematics. So if you are not familiar with, it's not a problem, and most often you will not use it in your programs. How we can use this function? As you see here, I say expx equal to math.exp. And here you will note that I use dot. So whenever I want to use a function from math module, you have to use this dot between the module name and the function that you want to use. And then you have to pass the argument to the function. In my case, I will pass x and I will check the result. If I run, as you see here, exp of x is equal to 54.5, etc. Now let's move to the next function, which is ifabs. Ifabs, it takes one argument and it should be float and returns the absolute value of the number that you have passed. So let's try this fabs function for x, and you will see that the absolute value of x is 4. If I make it -4 and run again, also I will get 4 because the absolute value in both cases, whether the number is positive or negative, it's positive. Now I will make x4 again, and I will move to the next available function in math module, which is in this case sqrt, or in other words, square root. And as you see, this function take one parameter, its name x, and it should be integer or float. And this function return a number which should be integer or float. And this function return the square root of x. If I want to try, I will say square root of x equal to math.square root x, and then I will print this variable. And as you see, the square root of 4 is 2. The next function is power. And power, it's a function that takes two arguments. The first one, x, which is the number, and then the power. In this case, it's y. And this will return x to the power of y. Now let's see an example. Power x equal to math.power x to the power of 3, which means 4 to the power of 3. In other words, 4 by 4 by 4. Run, I will get 64 as you see. One more function, which is logarithm function. And as you see, this function take one parameter, which is x. And this x should be integer or float. And there is another parameter, which is optional. And this will define the base of the logarithm. And this function returns the natural logarithm of a number by default. Or if you pass this parameter, which is base, it will give you the logarithm of a number to that base. Now let's see an example. The first example I want to show you here, that logarithm x math.log x, because I don't pass the base, so by default it's the natural logarithm. So if I run, I will get 1.3. If you want to pass the base, in this case, I will pass x and then the base that I want to calculate the logarithm for. And the result here, as you see, it's 0.86. Also, logarithm, it's a function, very common in mathematics, but most often you are not going to use it if you are a programmer. But if you are a data scientist or machine learning engineer, you have to understand exactly how logarithm work. Now let's move and talk about rounding function available in math module. Before now we see round function, and this function is available in Python, not in math module in Python, but in math module we have two functions that are very common to be used. The first one is ceil function. Now, let me show you how this function work and show you an example about this function. Ceil function, it's a function that take one argument and it should be float and return one argument or one number and the result is integer. How ceil work? It rounds a number upwards to the nearest integer and returns the result. Again, it rounds a number upwards to the nearest integer. So for example, if I have x equal to 3.5893 and so on, and I use ceil function for this value, what I will get? I will get 4. Why 4? Because it will round to the nearest integer upward. So 3.5, if I round it to the nearest integer, I will get 4. The next function that I want to talk about is floor function. And floor, it's the opposite of ceiling. Floor, it's a function that take one argument, which is x in this case, and return one number, which is integer. And it rounds a number downwards. So in case of ceiling, we say upwards. In case of floor, we say downwards to the nearest integer and returns the results. Now let's see an example about floor. Let me assume that x equal to 3.9 and then I use the function floor from math module, so math.floor. As you see, the result is 3. Why 3? Because I am rounding downward to the nearest integer, and in this case 3.9 is rounded to 3. And that's all about rounding functions that are available in math module. Also, math module is full by trigonometric functions, and these trigonometric functions are sine function. In this case, sine function take one argument, which is x, and it returns a number. Let's see an example. Let me assume x equal to 3.14 and I want to calculate the sine of x. As you see here, I will just say math.sine x and then it will return the result. Run. The sine of x, which is 3.14, in this case, it's almost 0. Python also have all the trigonometric function like cosine if you want, and you can use it exactly like sine, and you have also tangent function. You can try this function by yourself later on. One more function in trigonometric function which is very useful is degrees function. Degrees function, it's a very simple function that take one argument, and this argument should be passed in radians, and it will convert the value of radians into degrees. To see an example, let me convert the value of x, which is in this case x equal to 3.14. 3.14, it's in radians. So if I want to know how much it's in degree, as you will see, it's 179. If we write the complete number of pi in this case, we will get 180. The opposite of degrees function is radians function. And also this function is available in Python. Radians, it's a function that take also a number, it could be float or integer, and it returns a number. And this function will convert the value from degrees. So this function assumes that you pass a degree value and it will return the radians in this case. Let's see an example. Assume x equal to 180 degrees. So the radians of this value, it's math.radians. And if I print, I will get around 3.14 blah blah blah. The last point that I want to mention about math module, that also it has some mathematical constants like pi and e. And these mathematical constants are very common in mathematics. So if you are not familiar with, it's not a problem if you want to complete your career as a developer, but it's very important if you want to be a data scientist or a machine learning engineer. So how to get this constant? I will say math.pi, and you will not hear that I don't use parentheses because now I am getting a value, a number. I'm not calling a function. So pi equal to math.pi and run. You will see that the value of pi is 3.14. The next constant, which is very common in mathematics, is e, and it's called Euler number. How to get this number? Simply you say math.e and run. You will see that the value of e is 2.71 blah 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 and so on. Also, this is a very common constant in mathematics. And that's all for this code session. Now let's recap what we have learned in this lecture. First of all, we see that math module is a built-in module which comes with Python package and you don't have to install if you want to use it, and it's full of mathematical functions. Please, I want you to refer to Math Module Appendix file, in which you will find all the available functions in this lecture have been summarized. Also, please refer to the Math Module Challenges, in which you will find some challenges to practice what you have learned in this lecture. Thank you very much for your time, and join me in the next lecture if you are available.